Hello, and welcome to the DCD Cloud and Hybrids channel. Welcome back to the final episode of the Digital Realty Facility Tour. I'm Alex Dickens, Channel Management Team Lead at DCD, and I'm thrilled to be introducing this next episode, which will be exploring how data centres can balance the growth of AI workloads and their sustainability goals. Joining me, we have two expert speakers. I'm delighted to be welcoming back Patrick Lastinet, Director for Platform and Enterprise for Digital Realty, which we heard from in episode 1, and Colin Bannon, CTO for BT Business at BT Business. So, to get into it, I think we should spend a bit of time unpacking what exactly the AI workloads are. We've spoken a lot over the last couple of days about training, inference, but where are we up to really? Patrick, perhaps you could take it away. What do AI workflows currently look like?
Yes, thank you, Alex. So, first of all, a little bit more about me. So, I've been with the company Digital Realty for 13 years now. I'm focusing on our go-to-market for AI and HPC in EMEA, having worked with our key strategic partners on this front for quite a while. AI workloads, I would say we've shifted really in AI from a situation where a lot of the enterprises were considering this a little bit like shadow IT. We call it shadow AI, and now we really see an uptick in engagement from the IT, the CTO, in terms of managing these workloads. What we like to see and then to divide these workloads is in three pillars. First of all, I would say there is the initial stage, which involves ingest and consolidating of data. So typically you need to implement a data lake with structured, unstructured data. Connectivity and location is quite important for these data lakes, obviously. Second part of the workload is really where the magic is created. This is where you train your model. So using this data, neural networks, you then discover new patterns. You effectively generate new algorithms which enable you to gather insight or to perform or deliver specific outcome. So this workload, this is what we all hearing about currently, AI training. It necessitates extremely dense compute due to the usage of GPUs, which effectively allow you to parallelize compute at a massive scale. And finally, the third pillar of these workloads we call AI inference. So this is really once the algorithm, the relationship has been established, the algorithm gets deployed in an application for production for usage. And here, obviously, the critical factor is really the user experience, latency. So we're shifting a little bit from training, where it's all about high density compute, to inference, where latency, connectivity again matters a lot, and proximity to the users. So I would say that where we are today with the workloads is obviously there's been traditionally a lot of emphasis on the actual training side of things. We're now moving into inference because of the maturity of the workloads, and obviously with Gen AI. Gen AI is a little bit particular, so I will touch a little bit on Gen AI. The training involves large language models, so huge models, which are effectively very compute intense. And here, most of the enterprises we see sort of don't entertain the idea of generating their own large language model or training their own model. Rather, they will import it, fine tune it, and then run the inference. So it's a little bit of a different paradigm than the traditional AI, which then in turn gives rise to concepts like hybrid AI, where effectively you might import a large language model and then combine it with surely smaller type of models that you will have trained yourself. But in a nutshell, I would say where we are with those workloads is that finally the IT leadership is completely involved in designing and thinking AI dedicated infrastructure. But there is an enormous amount of complexity as well. There's a lot of fragmentation because all of this now overlays on hybrid IT. Yeah. So if you're an enterprise IT leader, you have your ongoing migration to the cloud, your hybrid IT strategy, and then you need to overlay thinking AI infrastructure.
Mhm.
So there's a I would say a lot of uncertainty still in terms of where to deploy, how to deploy AI workloads, but the benefits are enormous. So it's really top of mind.
hmm hmm And with the dynamics when it comes to training versus inference workloads, as you outline, against these other backdrops, in terms of power and security, sustainability targets, and this hybrid IT strategy you outline, we're also seeing rise of things like private AI, as we look towards more integrated environments. Could you perhaps talk a little bit more about what we're seeing there, Patrick?
Sure. So private AI, really the definition is importing a public model and using it on private data. Okay.
hmm
And effectively, you want to be the owner of your AI, so to speak. So all the intellectual property linked to your data needs to remain private, and therefore there's a lot of thought around having this infrastructure to a certain extent as private as possible. So within your DMZ, with your own data, your own compute, and dedicated networks, which is a little bit different from what AI used to be in terms of very specific um, traditional AI to identify patterns where enterprises were a lot more comfortable with just using big hyperscalers.
hmm hmm And it's down to choosing the right connectivity fabric. But what exactly do we mean by that? I think that tees up Colin quite nicely to perhaps outline.
Sure. And it's a pleasure to chat with both of you today. I think this is a an incredibly important topic for people to be discussing right now. But I don't think we have all the answers yet. And that's part of the reason why we should be sharing our ideas. Um, let's start about AI for a minute on the network. I think we have a pretty good idea of um, what the requirements for AI workloads are in the data center for Gen AI. You have very, very low latency between those processing nodes that are doing the training for Gen AI or other AI, pre-inference when you're doing all of that training. And there's a number of data centers around the world right now that are currently um, working very, very hard to do that training. However, what we understand less is um, the impact on the wide area networks of AI, both on the inference models and also on individual user workflows. Is it with the advent of inference models on devices or on data centers that are, from a latency perspective, closer to the customer in region? Does that is that going to have a reduction on our network traffic? Or if you start to, so having an inference model on a device, does that mean it has to call home less? Does that mean there's less packets being run on the wide area networks? Or does the advent of private AI or hybrid AI, where users and individuals, I mean, let's face it, the value of data has gone up. You know, every AI model wants all the data in the world right now to add value because now you actually have applications or um, AI platforms that can do something with that data. And obviously, from a privacy perspective, with private AI and hybrid AI, there is the concept of curating your own data model. So, collecting that telemetry, collecting that data back, pulling it back, does that increase the frequency of the interrogation of the user devices and the user flows? Is that pulling more data back from individual users? So, we may understand the networking model within the data center LAN. But I think over the next year, we're going to far better understand the advent of things like AI copilots, the overhead of curating data models. Could this actually be 2 times the data per user or more? And I'm one of the first people in the world who really wants to know this information on how I do the models for building global networks for the Fortune 1000 in over 180 countries around the world, this is something that's really, really important to me. And fortunately, we had made a set of investments on a platform called Global Fabric, which was really optimized for the concept of distributed workloads and meshing it together with the ability to scale up the bandwidth on demand, and it's all programmable and the underlay. And the underlay becomes a lot more important when you're starting to ingest things like petabyte databases into a data center provider who is then going to run a training model on that data, having the ability to scale up bandwidth for these ones, so that it's hours rather than weeks to get this data across, to get time to outcome, is really becoming quite important. So the one things that we know so far is that creating a platform and the investment that we made and the partnership that we did with Digital Realty was super important, because we sort of designed it for distributed workloads. And this is sort of distributed workloads times 10 with AI, with the requirement where you still have flexibility to get into the big iron data centers to do the training. So there are those head ends, and there's no bottlenecks in the pipes and the mesh, and connectivity for all the AI providers, including the SaaS providers, is super important. But also connectivity for the distributed workload for the data centers that are closer from a latency perspective, closer to the end users, where we can run slightly less intensive compute for the inference models is also super important. And having all those wired in, and we have a fabric that we're building right now that has about 700 data centers on net from that side. And also the concept of having edge compute right near the service provider edge will be important for inference models, we believe, as well. And in partnership with Digital Realty, we're doing some really interesting work there with fellow CTO Chris on the side. We're having a lot of time right now, sort of figuring out what our next big bets are on the very near edge, the service provider edge as well, which will be important from a latency perspective. And then, of course, an easier way to connect the end user customer sites onto a fabric to give them access to this, to reduce the friction of being able to do that. Because let's face it, AI is just another example of the fact that we've been learning over the last couple of years that applications have a certain propensity of where they should be across that. And it's not all in public cloud. There's huge arguments for it to be private, huge arguments for it to be in more regional locations. There's some argument, sometimes apps to be on-prem and working with the devices themselves. So the reality is, people and customers a few years back had the language of cloud first, and that sort of precluded. You sort of had the sort of attached thinking that it was only the CSPs, the public cloud providers. Now, all customers now sort of, they don't really use that term anymore. You see the term hybrid cloud or multi-cloud. The reality is that customers, first of all, they never got all their workloads into any one particular cloud provider. The reality was they ended up with a hybrid environment, um, A, because they perhaps weren't able to execute at the speed they thought they would, B, that the commercials didn't work out, and C, it just didn't actually make good sense to move all their workloads into public cloud. And there actually was a much more nuanced approach. So I'm seeing a lot more sophistication from our customers in terms of the making decisions on where the distributed workloads are placed, and the importance of having a deterministic network. Because let's face it, cloud is now, I would call cloud more the cloud way of developing agile DevOps and containerization and distributed workloads. So the mentality of hybrid cloud is workloads across where you need them, where it makes sense to have that app based on latency, but also based on economics. That drives it. And AI is just yet another ratchet that puts even more pressure on having a really well defined um, uh, uh, distributed workload strategy where you're choosing the right footprint of data centers and also choosing the right network fabric. Because after all, having a deterministic network is a precondition for these applications and for cloud to work. A lot of people for a number of years, the marketing teams would just draw this picture of a cloud, and there was no lines connecting it. And actually, you still do need a network, and it is very important, and even more important when you're talking about the sensitivity of making AI and Gen AI work. And if you think about some of the data payloads that are going to be moved around in the years ahead, even more so. So I think it's a really exciting time. I'll be the first one to say we don't know all of the implications of what's happening on the wide area network. And that'll take a couple of years to settle down as the use cases start to bed in and people use it in urgency. But I would say, I'll give you this one hint, is as SaaS providers start to urgent, urgently need to start marketing themselves as AI SaaS providers. I just came back from Mobile World Congress. Number one thing, every vendor site had AI in their booths, whether they had AI based on their own intellectual capital or they're partnering with an ecosystem that is providing AI capability. Now, what that drives is many of the SaaS providers today, where we had a linear flow between the user and that AI's my apologies, that SaaS provider's data center where they house their applications is now nonlinear because they're partnering with third-party AI engines to do some piece of work in their app to make it more intelligent. So you're seeing these idiosyncratic flows that used to go from A to B are now actually going A to C or to D and then back to B. So you're seeing new flows within the global networks that are pushing more data around in the back end. So we know data centers are going a lot hotter and moving packets around. And the back end of these journeys, where you're seeing ecosystems and SaaS providers using AI, you're seeing that heating up. And I think we'll start to see what happens to networks in the front end. But we certainly know there's this big heavy lifting that needs to go on there as well.
Brilliant. Thank you so much, Colin. So to dig a little bit deeper, but firstly, let's take a step back. We talk about AI and supporting AI services. Patrick, you spoke earlier on in a bit more detail about the training and inference dynamics we're seeing. We all know we're seeing scaling workloads, and obviously infrastructure will have to scale in line with that. But with requirements changing so rapidly, what is the reality on the ground when it comes to seeing new inferencing deployments?
Well, that's a good point, Alex. I think it is mainly a function of the pace of the change. So as a if you look at how fast we are going through the hype cycle, it's really fast. Certainly, in terms of the investments in training, a lot of the data center capacity. I mean, we have a global platform, and from our 350 plus data center across the world, we've seen across all continent demand for training, for data center inventory, for training workloads really explode. And a lot of that inventory has been converted into service training services. So the natural progression, once you start training those algorithms and those models, they need to run into production. And I think we are hitting that point as far as Gen AI is concerned. So we've seen tens and hundreds of megawatts being taken at scale. And now what we are seeing is the inference is a completely different type of uh, workload, so to speak. So we are, in a few hundreds of kilowatts, with some very precise requirements from the customer to actually have this remain private, no additional WAN costs, minimum latency. So, for instance, in the UK, where we have a big financial services community with customers traditionally trading high frequency on the markets, we're now seeing both them and the banks actually having more horizontal Gen AI applications that they need to serve. Um, so within a bank, if you are going to start implementing Gen AI for 20, 30,000 people, obviously user experience is front of mind, and you will want your inference environment to be closely connected to your wide area network. So we're starting to see these pockets of GPUs, again, far significantly less in size than training, but multiplying across our data centers with some very concrete demand from those who are the most advanced into Gen AI. And I would say financial services is traditionally um, very keen to capitalize on any type of innovation in AI. So we see demand from this. We also see more traditional inference, for instance, fraud detection, so payment processing, distributing the inference compute as close as possible to the point of sale. So, whereas in the past years, maybe you would have one compute region for those payment processors, they're now starting to adopt a topology which is similar to the hyperscalers, and they will tend to go in every tier one or tier two city. So, from one regional should we say, compute environment, they will have five or six across Europe with the TPUs, the inferencing there for fraud detection, and the proximity to the point of sale. So I would say it's really we going through again a very very fast degree of change within the IT leadership of I mean that the IT leadership has to face. And I mean, we talk in terms of years. If you talk about some of the service providers addressing this market, they talk in terms of quarters. This third quarter is inference. Inference going to hit, and there's a direct correlation between that timing and the availability of supply as well in terms of the right chipsets. So everyone is anticipating that by a certain time you will have the right chipsets on the market, and from there the use cases, the proof of concepts, if you want, will then evolve into something which is a lot more production ready. So it is quite fascinating to see the pace of change, I must say.
Brilliant, thank you. And Colin, I know you've spoken a fair bit about provisioning for AI workloads and the demands they're going to put upon networks, but this movement from training to inference must be another consideration, especially the scale or the pace at which it's going to scale.
Well, I think the inference is where the rubber hits the road at this point. I mean, we've spent a couple of quarters where people are taking beyond Gen AI on our sort of doing was it the deep neural network type training for inference models outside of Gen AI with their own curated models. And they spent the last couple of quarters trying to build improvements on the operating models that they do today and do that training and then have these inference models. And now the first generation of inference models that have been trained on these big engines are now starting to propagate, and people need to figure out where to companies need to figure out where the best use case of these are. And I'm seeing personally, and I can't speak for all, I'm sure there's other experts out there who might have other points of view, but I can see inference models that have been trained centrally in very large data centers with large data sets where there's an inference model for actually an end device, right? So that is one model. So we're seeing very small inference models for machine learning where like a video camera hasn't been improved. And I'll give you an example where um, you might have seen some consumer devices that have sort of plateaued in terms of the end user experience, a video camera being one of those. The last couple of years, it's sort of there hasn't been major improvements in what you've seen in the market. But with conferencing platforms, you see some people going, well, look, why don't I reduce the cognitive load of all the users are dialing in? Because post COVID, you've got this hybrid work environment. How do I get everybody's face the same size and everybody's eye level at the same eye level? And hey, half the people are in the office. Let's take them and put them in boxes as well, make their head sizes the same size. Let's democratize things so the people in the office are not biased towards the home users. All of that is done on the devices or nearby the devices, with relatively low latency using trained models. But then the interesting part of the training models that got interesting to me is, well, what happens about the person that's behind the glass wall that's back here, who's just working at their desk? And if you start getting the machine engine to do that, they might take their head and put it in the video. And so actually the training model is as much about taking out the false positives and getting rid of those, and training a camera with that learning model to differentiate that is actually somebody on the other side of the glass and they're not part of the conversation, versus all the heads that are in front of the glass sitting at the table along here. Now that has an impact on the devices themselves, but that's just one example that I'm seeing, that they spent a couple of quarters taking many, many videos, like taking all the sort of copies of actual calls, putting them in a central location and training the engine so that they could compact it down to a really tightly trained model that had a much lower compute payload that they could put near the edge to do this sort of, and that's a 30% improvement after maybe 4 or 5 years of stagnation of end user experience around inference. And there'll be a lot of models around that in just how people will operate their transactional processing, like Patrick talked about banks and payments and transactions, where sort of SaaS based or service based, they will need locations with a little bit bigger than an individual transaction that's running on a form of edge compute in data centers, for instance, in the UK, that are local, low latency, but are maybe not, doesn't have as expensive and bespoke equipment from NVIDIA that you might need, the mountains you would in the big training data center, that you can have this more, the benefits of a trained model, whether that be deductive or inductive. And there's many AI specialists who can talk about which inference various models use, and we'll see where the scores come out on that. You'll see that more on the edge, and I am seeing the prevailing trend that, just like distributed workloads, the previous applications that came before, that there is a propensity for latency. Now, if you're only going to have a few training engine big iron DCs around the world, it doesn't make good economic sense to build many of those. They're good for training. What you need is something that is more localized, more um, more immediate, more resilient. So you have a number of them, that the application experience is appropriate to the latency that you require. And I think with
Mm.
inference, there is actually, I think we can be confident to say that with inference now, latency is very important to that. And so there is a strong argument for having this model where you have distributed data and compute centers that are in region, that there's more of them, and then they're more available. I think the one thing we haven't talked about, of course, with sovereignty on data that may be collected and used with um, privately curated models, that some of this data may have sovereignty. So the concept of not using a CSP, but um, uh, um, a data center provider, like the sort of stuff that Patrick and team at Digital Realty are building, um, the concept of having private and secure in the UK is an important one, and we might touch upon that a little bit later. But those are a few thoughts from my sense.
Fantastic. Thank you very much. But before we move the conversation on a little bit, against all these issues that Colin's outlined, Patrick, in particular latency, but also against the wider kind of big ticket challenges when it comes to space constraints, power availability, and with this move from kind of training to inference workload emphasis this year that we expect, AI infrastructure localization, is that going to be the future?
Well, it still remains a challenge. Absolutely. I think it's interesting because even though what we've seen for those organizations who are really mature with their AI, I would call them AI companies, and all of a sudden you have a workforce essentially made of data scientists and data engineers. And if you look at their productivity and their usage of the training platform, that becomes a direct impact on your bottom line and your on effectively your time to market. And so we've seen even for training workloads some latency requirements, obviously, in the two-digit type of milliseconds. So if you were to open a new office in New York with a whole bunch of data scientists training new models for trading or something else, you will see that the actual cluster of GPUs will need to be within 10 milliseconds of the actual users. So it's really interesting to see. It will really vary from company to company, but definitely around the inference, it is a lot more latency sensitive. I think you don't really have the tension that you have today around training. I think what has happened today with training is almost a land grab. Obviously, the service providers anticipate and are positioning themselves to offer training as a service, if you want, to enterprises. And also, obviously, this comes with the right amount of GPUs and the right amount of data center space. So there's been a real tension on the supply due to the enormous demand. Um, I think it was Sequoia partner who quoted, for every dollar of GPU that is sold, you need to also spend $1 on data center, but then you need to recoup. And if you look at the margins, about $4 of AI service. So that there's been a massive investment into it, a training infrastructure, which now needs to be recuperated um, in terms of inference and new services. And this is where we're going to see, I think, the distribution of these inference nodes across, as Colin said, the effectively the an exacerbation of the distribution of the compute all across tier one, tier two locations. Um, and then all of a sudden, I think it's more you need to be where the subsea cables are. So you need to play on both fronts. The scale for the training as well as be at the right location in terms of connectivity and where the users are going to be in terms of the smaller inference deployment. And I think this is where our partnership with BT is really powerful because we will have obviously access to the on-ramps to the hyperscalers, but we need obviously a partner like BT for increased reach when it comes to serving all the inference requirements. And that becomes quite potent, and it's really exciting to see how fast we will be able to pass on those benefits to most enterprises.
Fantastic, thank you. I mean, as we've alluded to throughout this whole conversation, training, inference, all things AI are incredibly complex. But in order to make sure that we can withstand the challenges to come, we've got to make sure that robust underlying infrastructure is there. We've touched upon processes, partnerships, various players that will exist in this AI ecosystem. But even with the tech, if we don't have the right process to support, all of that underlying infrastructure, we're obviously going to run into some challenges there. We're hearing more and more conversation around the role of DevOps, in supporting infrastructure. Colin, perhaps you could, explain a little bit about what DevOps is and why it's so important right now.
Yeah, no, it's a great one. I might take it even further. If you look at how businesses today, my customers would look at DevOps in their own environments versus their infra people versus their network people, it would be very hard to get them in the same room today to talk about a single unified TCO because they're all looking at different things and they tend to have their own towers of how they procure and look at cost. So a application person who's doing DevOps will look at CPU, um, compute size, licensing size of their development. They might think about egress costs, whereas the infra people are thinking about, well, how do you move things from from the CPU to the MPU or the DPU and optimize on the hardware on that side with smart NICs. And then you have another group over the network team who are thinking about port size and packet throughput and DDoS and the scaling on that side. And when you have a procurement manager today with customers, they sort of they'll go, oh well, I've saved 5% over here in my one tower that own this business, and they're high fiving each other. But often they're moving the pain bubble to another tower. And I think the way that we do, the way we should look at this is from a both a from a an OPEX model. How all of a sudden the network this year with things like Global Fabric that BT created, the network now is a transformational tool to reduce the cost, the OPEX cost of running apps by many percent over in the dev area, the application area, which is a different tower, which is a different procurement cycle. So having that value conversation of stitching together more holistic TCO is important, but even more so from an operational assurance perspective and an availability perspective and an agility perspective, which DevOps come into very much. There's huge arguments for joining this all up. And I think from a skills journey as well within BT, we're moving from these individual towers of a DevOps team here, a net ops team here, and a SecOps team over here to sort of a net sec DevOps single unified field model of operating and thinking and skills. We've seen the network team and the security team come closer and closer together in terms of skill sets over the last couple of years. Security people need to understand networks, and network people need to start understanding security. And in many times, our vendors sell us rather than two boxes, it's actually one box now that both teams are logging on to administer. And this concept of the network, the ops team, the developer needing more compute, the ops team in the data center spinning up more processor, more memory at the speed that they need. And then they put a change order in to the network team for a firewall change, and they have to wait 6 weeks. It's not a good look in terms of the network team and the security teams not moving at the agility of a NetSec DevOps type world. The reality is the network team, in my view, what we've tried to be is part of the development team, so that if somebody wants to push some code, through their CI/CD pipeline, and they do a new feature release on a Saturday night, and they realize they're getting into trouble. Oh, Sunday morning you got before you go into full load on Monday morning. Hey, couldn't we use the network to generate synthetic load, as if there was all the users on the network on that app on the Sunday as part of the Q&A team, so that we all know that we're ready for trading on the Monday morning. And that's a bringing together of the two schools. I mean, after all, the network is the largest telemetry device for applications there is, but we probably use only 5% of the data for insight on that. And bringing those worlds together into A, for agility, B for outcomes and speed, and C for actual uptime, the way we actually work. One will make the other one, and D, of course, is the costs. If you start doing business cases thinking it is a joined up one, it becomes a hugely more powerful combination. It's not one plus one is two. It's more than that. It's greater than the sum of the individual constituent parts. Our skills will need to change, our culture will need to change, and the way we collaborate will need to change. But ultimately, it's really good news for the customer.
Colin, you broke that down
No,
incredibly well. And Patrick, sorry, I think you're about to say something as well.
yeah, no, absolutely. I think which is fascinating is these DevOps, NetOps, which even within an enterprise, this is the great divide traditionally between the two. And what we are seeing, I think, with the advent of AI and the stresses it puts on the infrastructure, you cannot afford to have a great divide between the what the enterprise user want is one pane of glass, possibly for all the MLOps development, but then it's NetOps counterpart. We want one pane of glass for all the underlying infrastructure, and somehow these two have to coincide and be synchronized as well. And so far it's been a little bit ignored because you had the cloud as a massive abstraction layer, so no one really thought about it on the MLOps side. But now it's really coming, to the front, and you need this symbiosis, otherwise it will, things will fall apart. Um, and I think what is really exciting, we try and also at our level to do orchestration of our service fabrics, that fits into the orchestration of global fabric from BT in order to deliver this single pane of glass as far as orchestration of infrastructure and network. And as we hit, the year of the inference, I would say, I think all of these benefits, this value will be very visible. And we see, the new GPU as a service provider coming on the market also think like this. They think top of stack MLOps, but they also certainly think in terms of orchestration of infrastructure. And I think these new innovators are accelerating the trend for this, rapprochement, should I say, between NetOps and DevOps.
Brilliant. Gentlemen, as all good conversations do, they tend to run out of time quicker than we expect. So I'd like to take a few more minutes just to explore, what the outlook is for HPC. We can't have a conversation without, giving our sentiment as to the evolution of the markets. Colin, I'll come to you first. Quite simply, how are demands and connectivity likely to shape up, throughout the rest of 2024 going into next year as well?
Yeah, I think there's going to be this incredible tension between, and I certainly see it in the networking side, of the sort of the watts per meg throughput on the network. And the network that we've just redesigned uses 76% electricity with 10x performance improvement, in some cases 100x, depending on what criteria you look at. And that's going to be really important in terms of efficacy on how you do this. But you just coming back again, we talked about coming back from Mobile World Congress. The pace of innovation is not going any slower. If anything, it is going faster, and the level of innovation that you're seeing coming from the Far East, in particular in some of the mobile applications, was shockingly strong. That was going on, yeah, and we need to be aware collectively to stay competitive. Businesses will need to innovate even faster. And one of the key ways to innovate is having really efficient architectures. The way you stitch together, not just high performance compute, but the way you stitch together high performance compute, um, will be more important than ever. And I am absolutely sure that not only will deep neural learning and AI and Gen AI continue to grow, but there'll also be approaches to look to make it more efficient and how you draw your topologies around it. And there will also be greater increasing scrutiny from the regulators on what you're actually doing with that data. And so sovereignty and where that data is going will also be important in many parts of Europe and other parts of the world. So you're going to see additional layers of scrutiny. So our approaches will need to evolve quickly, but I'm very confident that a high performance compute, there's only one direction is going. Yeah, we're just going to need to be more efficient on how we use our energy, how we architect it, how we treat that data, and there will, to serve all the great innovation and use cases that are coming down the pipe. And if we can deliver rock solid trust, whether it's trust on how we protect that data or secure it against threats, or how we protect the data from a sovereignty perspective to keep it sovereign, or how we protect and assure that they get rock solid performance and trust that this is never going to go down. And this is where partnerships with Digital Realty and BT come together to really make that happen, the true end-to-end experience for that. As long as we do those things, I think we'll have a bright future.
Mhm. And, in addition to that, end-to-end cohesive strategy, Patrick, from your perspective, Digital Realty have been designing adaptability, flexibility into your operations for some time. That's going to be, absolutely instrumental for, the HPC workloads and AI development that's to come, presumably.
Absolutely. I think we have a culture of engineering within the company. We have a quality of engineering second to none. We've been serving the most demanding customers when it comes to high density compute for quite a few years now. Um, and we now embark into a program which is to, if you want, try and standardize almost the modularity of what we're doing so that we can support at scale anywhere on the globe the type of workloads that we have, punctually supported in the past. So liquid cooling, obviously, different flavors of liquid cooling, rear door heat exchangers, but direct liquid to chip and potentially immersion. We need to, and we are accelerating, if you want, the final design to support all of these in multi-tenanted data centers wherever the customer wants. And this is not a small feat because when you manage a multi-tenanted data center, you need to think not just of one or two customers, but you need to be able to provide the best service to a variety of customers who will all be on a different journey and a different level of maturity when it comes to the compute. So this is really the focus for us. And this obviously comes with some tremendous responsibility as far as the sustainability is concerned, energy efficiency. Obviously, we design, in terms of renewable energy, 100% renewable in all our colocation data centers across the world. A big focus on the efficiency in the PUE, but this is just one aspect. Efficiency is often relates to costs, not necessarily just sustainability. We also want to double down on our strategy of virtual PPAs, which means that whenever we build a new data center, we try as much as possible for it to be matched with a new source of renewable energy locally. So effectively, whenever we bring a new data center to market, it contributes to reducing the carbon intensity locally, which I think will be necessary given the demand. I think in terms of HPC, to Colin's point, traditionally HPC has been, we can tolerate 3 nines of uptime and one power feed. This is in the days of HPC being used for academia and research. Now that HPC becomes mission critical, you need to look at all those workloads with 5 nines and even more in terms of SLA and guaranteeing SLA. So again, a new level of design. Know-how is so important. You need to have faced a few challenges before implementing these, before scaling the right processes globally. But it's extremely exciting. um, I think everyone is learning a little bit as they go along. But if you stick to your, you know, principal values, which is provide security, provide the best possible um, services and operational excellence, and also have some, you know, proximity to the key customers who are driving this change. I think this is going to be very, very exciting.
Fantastic. I think that's a great place to end on. So, that is all we have time for today's facility tour. But thank you so much to all our expert speakers, as well as all our audience members who tuned in, as well as all the questions that came in. They will be passed on to the sponsors. As I mentioned, this is the final episode of today, so it will be available on demand shortly, along with all our other content. We hope you enjoyed yourself. If you have any feedback, please do submit it to us. And as we said, if you have any questions, please reach out to Patrick, as well as the wider Digital Realty team, who'd love to hear from you. We'll be back at the same time next month on the Cloud and Hybrid channel with more episodes, and we look forward to seeing you then. Thank you.